Allow me take this opportunity to welcome you back to this other session of ours. And now in this session, we are going to look at the Mendel's experiment. Now we are saying this man Mendel collected one of the varieties of garden peas with the contrasting features, such as one variety producing tall plants and another shorty plants. This man Mendel did a very great job in genetics, whereby he chose to use garden peas in his experiments, and because these garden peas had the contrasting features such as height, as we are seeing that this man used the tall pea plants and the short pea plants. Then we are saying he crossed these plants for his experiments. Then he crossed pure tall pea plants with the short pea plants, and all the F1 generation was what? Was tall. The word pure tall tea plants, it means these plants had the capital T as their what? As their alleles. So, and these ones had the small t since they are what? They are short. We are saying that tallness was the dominant. Dominant means it had the more powers of expression than other genes. Then we are saying that tallness was the dominant character and shortness was the recessive character. Now here we are saying that the dominant character is represented by a capital letter. Always when you are crossing, your dominant character must be represented by a capital letter, and the recessive character is represented by a small letter. So allow me to take you through the crossing of Mendel. This was the crossing this man Mendel carried out. We are saying that before you cross, what you should do first, you should first of all label or identify the alleles. So we are saying that let T represent an allele for tallness, and you let small t represent an allele for shortness. Then after that, the word allele means an alternative form of a gene. Then you have what we call the parental phenotype. Here, the parental phenotype, we are saying that this man Mendel crossed the tall pea plants with the short pea plants. Then the parental genotype, here we are having capital T, capital T. Now these are the genes. We are saying that capital T is dominant, and this is a pure tall plant. Pure means it is having both capital T, capital T. Then recessive, it has got small t, small t. Then from there, we go ahead and look at here. Now to separate these genes, we have to go through meiosis. Now meiosis separates this one to have capital T with a ring, as you can see. Now these ones become our gametes, and this side we are having small t. Please you put them in the ring, and this becomes our gametes. Then from there we got the interesting part here. This part we have what we call random fertilization, whereby this one capital T goes with the small t the other side, like this, to have capital T, small t. Then still capital T crosses itself with another gene the other side, sorry, another gamete the other side. Then we have capital T, small t. Then still we have this one goes with this. But here people find problems, most especially the learners. You cannot begin with the small t here. You get? You always begin with the capital T because this T is dominant over this small t. It is having more powers of expression than this. That's why we always begin with the capital T, small what? Small t. Then even this one goes with the other one. So we have capital T, small t. Now these ones are called the so-called what? Offsprings. Now we will see that the F1 generation, or F1 offsprings, all are what? All are tall in F1 generation. Then we go on and cross with selfie. So selfing means you are going to get one male parent from this and you cross it with another female from this. So since we are saying that the F1 generation all are tall, then selfing, we say parental phenotype. Here we are having tall P plant now being crossed with the tall P plant. Then the parental genotype, we are saying that the capital T small t is crossed with the capital T small t. Then here we have meiosis. I have capital T as a gamete with the ring, small t like this, and even this one comes with this one, as you can see there. Then these ones become our gamete. So we are saying from there we have now random fertilization, whereby this goes with this. We can have capital T, then this goes with this. We are having capital T small t, then this comes with this. Here we are having capital T small t, and this comes with this. Here we are having small t. Now the phenotypic ratio is 3 are tall and 1 is what? Is short, as we can see. This one is tall P plant and this one is also tall P what? Plant. Because we say that this capital T has is dominant over this, has more powers of expression than this. So we are having capital T